In this lesson, we'll be looking at histogram. It's a continuation of our previous class where we looked at pie charts, which is a method of representing a given data in a circular chart known as pie chart, whereby each sectorial angle represents the size of the given data. In this lesson, however, we'll be looking at another way of representing data, which is by the use of histogram. Now, if you recall from one of the previous classes, we learned how to represent data using bar charts. Bar charts and histogram are kind of similar. The only difference between them is that in bar chart, there are spaces between the bars. In histogram, there are no spaces. So permit me to read from the board. We say histogram is a graphical representation of a frequency distribution. They are rectangular bars placed side by side. The vertical axis represents the frequency, while the horizontal axis represents the variable being represented. The class boundary is written on this horizontal axis. If you have taken the previous classes, you should know what a class boundary is. So the area of each rectangular bar of a histogram is proportional to the corresponding frequency. The histogram differs from the bar chart in the following ways. Number one, no gaps between the bars. And number two, the histogram can be used for group data. So how do we draw a histogram? We have an example here on the board which says, the following is the record of students offering various subjects in a high school. Chemistry 9, Physics 12, Technical Drawing 4, Economics 11, Home Management 16, Yoruba 6. Construct a histogram for the distribution. So I'm going to make use of this graph on the board to construct the histogram representing this data. Like we said, a histogram is a kind of a graph whereby we have rectangular bars representing the size of the data. But the rectangular bar, there are no spaces in between them. So we need ruler to do that. And this is the vertical bar. Okay, so let's indicate our x and y axis. This is the y axis on the graph. And this is the x axis. The next thing is to choose a scale. Let me assume that from here to here is 1 centimeter. The distance between one board line and another board line, I am assuming is 1 centimeter. For a standard wire graph, the distance between one board line and another board line is 2 centimeter. But here, this is not a wire graph. Okay, it's actually 2 centimeter here too. So this is a standard graph. So let's use 2 centimeter to 2 units, whether it will be enough. We have up to 16 here, home management 16. Here is 2, here will be 4, here will be 6, here will be 8, 10, 12, 14 to be enough. 2, 4, 6, 8, 10, 12, 14, and lastly 16. Okay, the next thing now is to represent the data on the graph. The first data I have here is chemistry, which is 9. Let's locate 9 on the graph. 9 is right here. Remember, it is histogram we are drawing. So we'll leave one space from the y-axis, that is the first data, chemistry. Let's draw everything before I label it. And the second one is physics, which is 12. So remember, for histogram, there are no spaces in between. So I'll just locate my chart right here and draw the line connecting this one. And the next thing, the next one is technical drawing, which is 4. Let's move on to 4. The next one is economics, which is 11. Let's go to 11 right here. This is 10. 11 should be in between somewhere here. Then we have the next one, 16, home management. And finally, we have Yoruba, which is 6. Okay. And now label each of the data coding. The first one is chemistry. We shorten it to chem. The second one is physics. We shorten it to PHY. The third is technical drawing. I will shorten it to TD. The fourth is economics. Shorten it to econs. Then we have home management. I will shorten it to HM. And finally, Yoruba. Shorten it to Yoruba. Okay, that is a histogram representing this data.